Hello students, till now we have studied about circular motion on horizontal level roads, bank roads or circular tracks, but now in this video we are going to study about motion in a vertical circle. Now vertical circle means we can understand it with an example. Suppose I have this eraser, I tie it to one end of a string and hold the other end of the string. इसको मैंने एक string से बांधा है और उसका दूसरा end मेरे हाथ में, and then I am moving it like this, means in a vertical circle like this, just like small kids playing games. So this is a vertical circle, and now we are going to study about the motion in a vertical circle. Here is the diagram which is showing. Now this diagram I have made a circle. Now this is not in the plane of this paper, it is perpendicular to the plane of paper, it is a vertical circle, and here the point L I have considered for reference at 0, and above it we will count the height. The height will start from 0 at the point L. So to understand this topic, we are assuming an object of mass m tied to one end of the string, right? So we have considered an object which is tied to one end of the string and is rotating in a vertical circle, and it is rotating in a vertical circle. Now we are considering that the radius of the circle is smaller circle, and iska jo radius hai that is r, that we have assumed, and we are showing it in this diagram. This is a circle of radius r in which the object is rotating vertically. So now velocity, we want to find the velocity at any point, means general velocity at any point during this whole motion. So for that, velocity at any point we are trying to find, and for that we assume the body passes through the lowest point. This is the lowest point, capital L, and this is the highest point, capital H. So to find the velocity at any point, we assume that the body passes through the lowest point with velocity u. So u is the velocity at lowest point at L, velocity is u, and through that it starts moving and it comes to point capital P, any point capital P, and at that point capital P its velocity is v. Now we have to find this velocity v. While moving from L to P, from this to point this, the object has moved up through a vertical distance h, means यहाँ अगर उसका height 0 था, then it moves to a height h while coming to point P. Okay, so the height or vertical distance covered by the object while moving from L to P. So from L to P, object moved up to height h, right? H is the height between L and P. Now by applying the law of conservation of energy, we can say that during the motion at every point total energy of the object remains same. That is the law of conservation of energy. Okay, so at point P, the vertical height, this h is the vertical height Ln. Now according to law of conservation of energy, what we know is at every point the energy of the object will remain same, the total energy of the object will remain same, and this total energy comprises of its kinetic energy plus its potential energy. So total energy of the object at L, that means its kinetic energy plus potential energy at L will be equal to kinetic energy plus potential energy at P. This is according to the law of conservation of energy. Now at this point, if we consider it as a reference point, then it will be at height 0, and if it is at height 0, its potential energy will be 0. So at point L, the kinetic energy is half mu square plus potential energy is 0, while at point P its kinetic energy is half mv square, because at point P we have considered the velocity v, and it travel a vertical height of h, so its potential energy is mgh. Now by rearranging this equation, we can get u square plus v square, u square equal to v square plus 2gh, and by solving this we can get the velocity v equal to under root u square minus 2gh, which is the velocity of the object at point P or at any point at height h. Means this is a general point. If you put different values for h, we can get different values of v for different points or different locations during that rotation in a vertical circle. So this equation gives us the velocity of the body at any point. Let it be equation number 1. This is the first thing. Now the next thing that we have to find is the tension along the string at any point. This was velocity, and now the second thing is tension along the string at any point, right? So again we have considered the general point P. हम इसी point पे tension भी calculate करेंगे. So this is T, and we have to find the tension T at point P. So for this, the forces acting there are, first is the weight mg that is acting downwards, right? This is the weight mg that is acting downwards, and if this point P has the line joining the point P from the center making an angle theta with the vertical, then this angle will also be theta, and we can do the components of this weight mg, and it will be mg cos theta along the radius and mg sin theta along this tangent, right, at point P. So the second thing that is acting here is the tension T of the string, and if we write force equations as per the diagram after components, we can see that this particle or the object at point P is tied to the string and moving in a circular motion. So there is a centripetal force, and that centripetal force comes from the forces acting on this particle. Now the forces acting on this particle is the tension T and mg cos theta, which are in opposite direction. So their difference will provide us the required centripetal force. Since the centripetal force act towards the center only, then particle move in a circular track or in a circular motion. So that shows us this tension should be more than mg cos theta, only then this will work. So we can write force equation as T minus mg cos theta will give us the required centripetal force mv square upon r. This is equation number 2, right? Now by substituting the value of cos theta and velocity for this point P, we can get tension. So tension is equal to mg and the value of cos theta from the triangle OPN. From this triangle, if we try to find cos theta, it will be base upon hypotenuse, and for angle theta, base is r minus h and hypotenuse is this radius. This is the radius of the circle, that is r. So cos theta will be r minus h upon r plus m upon r, and in place of v square we can write u square minus 2gh. Okay, so on solving this we get the tension at point P, and it will be m upon r u square plus gr minus 3gh. Just by solving these two values we can get the value of tension at the along the string at point P. Now there are two special cases for this value of tension, that at the lowest point and at the highest point. So first I am talking about at lowest point. If we talk about the tension at lowest point means we are talking about the point L. So at point L, this value of h will be 0. At lowest point h will be 0, and we get tension is equal to m upon r u square plus gr, right? This is equation number 3rd. At highest point, if we talk about the highest point, so from L to H, the height will be double of that of radius. If you see the distance, so this is 0, then this will be r plus r. So in case of highest point, the value of h will be 2r. We can substitute it in this equation and we get t is equal to m upon r u square plus gr minus 6gr, right? And on solving this, we get t is equal to m upon r u square minus 5gr. This is equation number 4. And if you see the difference between these two values, this is the tension at lowest point, this is the tension at highest point. If we want to find the difference of these two values, then we get the difference is equal to, this difference will be equal to 6 mg. So the difference between the two values is 6 mg. That means the difference in tension at the lowest point and the highest point is equal to 6 times the weight of the revolving body. जो भी ऑब्जेक्ट हमने स्ट्रिंग से टाई किया है उसके वेट mg का 6 टाइम इज इक्वल टू द डिफरेंस बिटवीन द टेंशन at the lowest point and at the highest point. Similarly, there are certain cases for the velocity of projection also. So let's see that. Next point is the minimum velocity of projection of that body at the lowest point L. So how much velocity u is needed so that the body show that rotation instead of slacking of the string, means वो उस rotation को पूरा circular form में हमें show करे, it go from L to H and come back from H to L in a circular motion. उसके लिए कितना initially point L पर lowest point पर velocity देना needed है, that we are going to find. So in this condition, if you want the circular motion for without any slackening of the string, a condition is if we want body to cross point H, that is the highest point, without any slackening of that string, then for that the tension at the highest point th should be greater than equal to 0. This is the condition. For that the tension should be positive. Greater than equal to 0 का मतलब है that tension at the highest point should be positive. Now we have calculated th already. Its value was m upon r u square minus 5gr. So this value must be positive, means it should be greater than equal to 0, or u square minus 5gr should be greater than equal to 0, which implies u should be greater than equal to under root 5gr. So we can say that u should always be either equal to or more than this value for that circular rotation of the object. That means this is the minimum velocity needed at the lowest point for the body to possess that circular motion or for the looping of that loop. Means this is the minimum velocity needed at lowest point for looping the loop, right? अदरवाइज क्या होगा, ऊपर जाते जाते वो बीच में कहीं पे से ऐसे सीधा नीचे आ जाएगा. दैट वी डोंट वांट, दैट इज कॉल्ड स्लैकनिंग. So we don't want the slackening of a string. For that the minimum velocity that we should provide at the lowest point is under root 5gr. Now next thing is the minimum velocity at the top. Now if we give this much under root 5gr, that is the minimum velocity to the object, and it reached to point at the top, that is point H. So what will be the minimum velocity of that object at the top? So minimum velocities correspond to the minimum velocity given at the bottom. We have calculated for any general point at height h, the velocity can be given as v square is equal to u square minus 2gh. Now if the object is at the highest point, that means at highest point h should be equal to 2r, that is double of the radius. So for that case the minimum velocity can be given as v minimum square is equal to u minimum square minus 2g, and in place of h we have to put 2r. So u minimum square is 5gr, this is minus 4gr, and the value is for v minimum square. That means v minimum is equal to under root gr. So this is the minimum velocity at the point, at the highest point, or at the point h. So this is the minimum, or we also call it as the critical velocity at the highest point. Minimum velocity, or we call it as critical velocity at the highest point, that means at h, right? Okay, now next thing is, what will be the condition for oscillation? Now there are two situations. If body is not rotating, for the rotation of a body, or for the looping of the loop, this much velocity is needed at minimum, at least this much velocity is needed. But what if the velocity u is less than root 5gr? Then there are two cases possible, that either the body will start moving towards the highest point, but instead of going there, it will come back and show oscillations, first thing, or the body will leave the circular path. There are two possible situations. Now the condition is, if the minimum velocity at lowest point is under root 5gr, but we give the velocity at lowest point, it is less than that minimum velocity, means u is less than under root 5gr. In that case, there are two situations possible. First situation, the object will show oscillations, okay, and the second situation, body leave the circular path. Now there are two forces acting there, the tension T and mg cos theta, opposite to each other, and the difference is providing the required centripetal force towards the center. That means T is greater than mg cos theta. That's why that body is moving in a circular motion. So to find or to understand this situation, whether it is oscillate or whether it will leave the path, we have to find two things. First, we will find a height h1. It will be the height at which the velocity of the body becomes 0. Means h1 is the height jahan par v is equal to 0 hoga. Next, we have to find the height h2. This will be the height at which the tension in the string becomes 0. Okay, so these two heights we have to find. Now if the height h1 is less than h2, situation 1, if the height h1 is less than h2, in that case there will be tension in the string, but its velocity becomes 0. Means if the particle is moving like this, it is moving like this in a circular path, this is height h1 and this is height h2. h1 is the height जहाँ पर velocity 0 है, h2 is the height जहाँ पर tension 0 है, and h1 is below h2. So particle will go till h1, it will stop there and come back. So in such situation, it will show oscillation, because there will be tension in the string and it will be connected to that string. Means the body will oscillate. This will be the condition of oscillation. When h1 less than h2, the body will oscillate, and it means the velocity becomes 0 earlier than the tension. Okay, the velocity is becoming 0 earlier than the tension, and at that time it is showing oscillations. But if the height h2 is less than h1, that means if the body is going like this, and this is height h1 and this is height h2, means tension becomes 0 earlier than the velocity becoming 0. In that case, since tension becomes 0 at the point here at the height h2, so body will leave the circle and there is no significance of velocity getting 0. So in that case, when tension is becoming 0 earlier than the velocity, the body will leave the circle. So to get these conditions, first thing is to find h1 and h2. So let's see how we find h1. h1 is the height at which the velocity becomes 0. So we know that the velocity is v square is equal to u square minus 2gh, and we want it to be 0. So for v is equal to 0, we get 0 square is equal to u square minus 2gh, height corresponding to it will be h1. So h1 will be, यहाँ हो जाएगा h1 का वैल्यू u square upon 2g. So this is the height h1, जहाँ पर the velocity will be 0 at the point corresponding to height h1. The velocity v will be 0. Now for h2 where tension is 0, so for that we have to use the relation of tension, expression of tension, that is T is equal to m upon r u square plus gr minus 3gh. And if we take T is equal to 0, that means 0 is equal to m upon r u square plus gr minus 3gh2, because we are assuming that h2 is the height jahan par tension is getting 0. On rearranging this, we can get the value of h2 is equal to u square plus gr upon 3g. Now for oscillations, the condition we have is h1 should be less than h2. So if h1 is less than h2, in that case oscillations will be there. So for it the condition will be u square upon 2g must be less than u square plus gr upon 3g, right? And on solving this we get 3u square less than 2u square plus 2gr, or we get u less than equal to under root 2gr. So this is the condition. That means if the value of u is less than under root 2gr, in that case the body will show oscillations. The body will oscillate about the lowest point of the vertical circle if u is less than under root 2gr. If u is equal to root 2gr, the path of oscillation will be a semicircle. This is the situation that if u is equal to हो जाएगा root 2gr के, if u is less than root 2gr, it will show oscillations. If u is equal to root 2gr, its path will be, it will show oscillation, but its paths will be semicircle. It will track the half circle, so its path will be semicircle. Now for second case, for that the body will leave the circle is h2 less than h1. So for that the condition we have is u square plus gr upon 3g must be less than u square upon 2g. And on solving this or rearranging this, we get u is greater than root 2gr. So if u is greater than under root 2gr, in that case the body will leave the circle. There will be no oscillation about the lowest point. So what condition we have here, we know that this will all happen only if u is less than u minimum. Okay, so maximum value is this. इससे नीचे के velocities पे either oscillation or body will leave the circular path. These two conditions are possible. So for the velocities less than under root 5gr, there are these situations in which our velocity at the point, at the lowest point, if exist between under root 2gr to root 5gr, if this is the situation, then the body will leave the circle. Body leave the circle. But if this velocity at the lowest point is equal to root 2gr, body will trace semicircular path, and if it is even less than root 2gr, it will oscillate about the lowest point, that is L. Okay, so this is the case whether we get oscillations or body will leave the circular path. That's all for the video. For further videos, stay tuned and keep studying. Thank you.